Hi, everybody. Let's do IXL 6th grade CC.16. Go to Learning, go to 6th grade, then go down to CC.16 Identify Complementary, Supplementary, Vertical, Adjacent, and Congruent Angles. What are those? Let's go over to friedmanmath.weebly.com. We see the reference pages here. We see that angles is on page 14. So we will scroll down to page 14. Here it is, page 14. And I'll make that a little bigger. There we go. Okay, we are going to be mainly looking at these two sections, naming angles and angle relationships. Let's go to naming angles first. Pretty simple. The symbol that looks like this is used when referring to an angle. Angles are often named with 3 letters, the middle letter in the name being the vertex of the angle. The vertex is the point where the 2 lines meet. So these 2 lines over here would meet at this vertex here, the point where they meet or intersect. And this is the angle between them, the amount of rotation between them. But right now we're just interested in how to name the angles. So what if I wanted to name this angle right here? Just give it a name. What would I call it? Well, we could call that, since it goes from A to B to C, as you can see here, A, B, C. Let me try that again, because I don't know if you can still see the letters. A, B, C. That's the name that we would give to this angle, ABC. And you can see here that I drew a little, or put a little snake in there. So angle ABC has the snake in it. Now you could also call this angle over here CBA. Okay, it's the same angle, we're just giving a different name to it, CBA instead of ABC. You can use either one, and you can see that no matter which way we do it, B, which is this vertex over here, ends up being in the middle of the letters. Okay, I'm not going to go through all the rest of them. I want to move on now to angle relationships over here. Now, in a previous video, we talked about complementary and supplementary angles. Complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Those are the definitions of complementary and supplementary angles. And here's another definition. Congruent angles are angles that are equal to each other. Okay, so this angle here, which is 20 degrees, is congruent to this angle here, which is also 20 degrees. So congruent is just a fancy word for equal. Okay, that's simple enough. Let's move on to adjacent angles. Adjacent angles are next to each other. So if you see 2 angles that are next to each other, you can call them adjacent. Let's be a little bit more specific. More specifically, they share a common side between them and a common vertex. So before I read on about linear pairs, let's go over to these examples over here and see what we mean by that. So you can see that these 2 angles here, which I called angle A and angle B, they are right next to each other, which means that they are adjacent angles. So adjacent is just a fancy word for next to. But these angles here, angle C and angle D, also kind of look like they're next to each other. But they are, in fact, not adjacent. So if they kind of look like they're next to each other, why are we saying that they're not adjacent? Well, we have to really be clear about what we mean by one angle being next to another angle. We mean that they share a common side and a common vertex. Well, you can see over here, angles C and angle D, they do share a common vertex right over here. That's the point where the two lines that make up each angle intersect. However, they do not share a common side, right? Angle C is made up of this side and this side. Let me use the marker. Angle C is made up of this side and this side. I'm sorry that that's so thick. There's no way for me to make it any thinner. Angle D is made from this side here and this side here. So you see that they do not share any common sides. On the other hand, back over to angles A and B, angle A is made from this side and this side, and angle B is made from this side and this side. So this middle side here is the same side for both of them. So not only do they share a common vertex, which would be right here, they also share a common side between them. So that's why we say that A and B are adjacent, but C and D are not adjacent. Now, what about these other angles, G and H? G and H, these angles are next to each other, and more specific, they share a common side and a common vertex, the point where the two lines that make each of the angles intersect. Over here, again, I and J kind of look like they're next to each other, but why are we not calling them adjacent? It's because they do share a common side over here. I'll do that in the same color that I did the last one. They do share a common side over here, but they do not share a common vertex. So J has its vertex right over here, but I has its vertex right over here. So that's why we're not calling them adjacent. All right, let's move on to linear pairs. So I'm reading from over here now. Linear pairs are a special case of adjacent angles. That means that a linear pair is a kind of adjacent angle. So all linear pairs are adjacent angles, but the converse of that is not true. Not all adjacent angles are linear pairs. So linear pairs are adjacent angles that form a straight line together. Okay, so let me go over to this example over here. I have angle M and I have angle N. Are they adjacent? Yes, they are adjacent. You can see that they're next to each other. You can also see more specifically that they share a common side between them and also a common vertex right over here. So they do meet our definition of being adjacent. But more than that, you can see that they also form a straight line together, right? They form that straight line. In other words, if I start over here with angle M, so I go from here to here, and then I go through angle N from here to here, So angle M is just, well, this is real. You know what? Let me try making this bigger. Let's see. Yep. Okay. Well, that's bigger. And here we go. Still not sure that it's big enough, but we'll try it. So angle M goes from here to here. Angle N goes from here to here. So if we start with angle M and then go all the way through angle N, then we're going from here all the way to here, and we just made a straight line, right? So in other words, we started here, and then we took this line all the way to the other side over there, and we have a straight line. And a straight line, the angle measure of a straight line is 180 degrees. Okay, so linear pairs are adjacent angles, angles that are next to each other, that also make a straight line together. Okay, and it's easy to remember because what word do you see in the word linear? Actually, you see a few words. You see the word, well, the word line is right there inside linear. Actually, there are a few words in there. You could also say that ear is in linear. The word I is in linear. The word a is in linear. The word near is in linear. So every time I ask that question to my classes, people always jump in with a lot of different answers. But the answer that we're most interested in right now is the word line. So you can see that the word line is right there inside the word linear. So that makes it easy to remember. All right, so I'm just going to read. Okay, so I talked about this already. Because linear pairs form a straight line, they add up to 180 degrees, which makes them supplementary. Because remember, over here, 180 degrees, that's a straight line. A straight line is 180 degrees if we go from here all the way around to here. So we made a straight line. And by definition, if angles add up to 180 degrees, then we call them supplementary. So linear pairs would be supplementary. Okay, this over here is not a linear pair because even though the angles are adjacent, so they share a common side and a common vertex, they do not form a straight line together. This is not a straight line, so these would not be a linear pair. If we added K and I together in this case, then, or K and L rather, then we would get an angle which is actually bigger than 180 degrees. So it's not a linear pair. Now the last kind of angles that we're going to talk about, and this is actually very important, you're going to see a lot of this in the IXL exercise, are vertical angles. What are vertical angles? Well, vertical angles are angles that are on opposite sides of two intersecting lines. So you can see, let me jump down to the example. This line and this line here intersect, and they create actually four angles. So, and the angles which are vertical to each other are the angles which are on opposite sides. So for example, this angle and this angle would be vertical to each other, and this angle and this angle would be vertical to each other. Okay? Now over here, we can see if we look over here at these other angles, which I called, it's hard for me to even read what I wrote. I think I called that S and this one R. These angles are actually not vertical because we can see that angle R was formed by this line and this line, but angle S was formed, it did share this line together with angle R, but not this line over here. Angle S was formed by these two lines, this line and this line. So it was not formed by the same two lines as angle R was. So angle S and angle R, even though they kind of look like they're on opposite sides from each other, they are not considered vertical angles. Now here's something very important to know about vertical angles. Vertical angles are always congruent. What does congruent mean? If you recall from what we said earlier, congruent angles are angles that are equal to each other. So you can see in this drawing here, angle P, if you were to actually take a protractor and measure that, angle P would have the exact same measurement as angle Q. Okay, so this angle right over here is exactly the same. Oh, it's smaller now. I don't know how I did that. Oh, anyway, this angle is the same as this angle over here. And also this angle, which I did not name, is the same as this angle over here. They would be congruent to each other. But you can see that angle S and angle R are actually not equal to each other, right? So vertical angles are always congruent or equal. All right, so that was a kind of a long introduction. I hope it made sense. Feel free to rewind if you missed anything. Let's go ahead and do some IXL exercises. Which angle is congruent to angle 1? Okay, so angle 1 is this angle over here. You can see 1 means this angle, oops, this angle right over here. Oh, it got even smaller. I don't know how I'm doing that. I like it, but I don't know how that happened. Okay, so that's angle 1. Which angle is congruent? Remember, congruent means equal. So which angle is equal to angle 1? Well, we can see that angle 1 is formed from this line here and also this line over here. And if I just extend those lines, so if I take this line and extend it this way, and take this line and extend it that way, you can see that angle 1 and angle 4 are on opposite sides of two intersecting lines. That means that they are vertical by definition. Now, what do we know about vertical angles, angles that are on opposite sides of two intersecting lines? We know that vertical angles are always congruent. They're always equal to each other. And in fact, if you look at the picture, if you just eyeball it, you can see that angle 1 does look like it has the same measure as angle 4, right? And in fact, they are exactly equal to each other. So we will select angle 4 for this one. All right, which angle is complementary to angle 3? Well, what does complementary mean again? Complementary means that the angles add up to 90 degrees. So angle 3 is right over here, That's angle 3. And I'm also going to outline the line segments which create angle 3, which are these two line segments right over here. So what are we looking for now? We're looking for another angle that, when added to this angle, gives 90 degrees. So angle 3 by itself is not 90 degrees, but it kind of looks like that when we add angle 3 and angle 4 together, so here's angle 4, so you can see from the picture, it looks like if we start over here and go through angle 3 and then through angle 4, it looks like we just made a right angle, which is 90 degrees. Now, you have to be careful here because even though it looks like a 90-degree angle, it might not actually be a 90-degree angle. How can I prove that angle 3 plus angle 4 actually is a 90-degree angle? Well, if you look right over here, IXL is using this little square symbol, which we know that little square symbol. If we go back to the reference pages, that little square symbol means that that angle is 90 degrees. So I know that this angle right over here is 90 degrees. I know that because because I see this little symbol here. And what do I know? What happens if I take this line and extend it this way, and take this line and extend it this way? I can see that this angle and this angle are actually vertical angles because they are on opposite sides of two intersecting lines. And what do I know about vertical angles? I know that they are congruent, meaning equal, so that if this angle is 90 degrees, remember we have this little symbol here, this angle must also be 90 degrees. So yes, so angle 3 plus angle 4 do in fact make a 90-degree angle, and therefore angle 4 is complementary to angle 3, meaning they add up to 90 degrees. Alrighty, let's try the next one. Which angle is supplementary to angle 2? So angle 2 is this angle right over here, which is formed from this line segment and this line segment. And I see this symbol over here that is telling me that angle 2 is a right angle, meaning it is 90 degrees. Okay, and I'm trying to find an angle which is supplementary to angle 2. What does it mean to be supplementary again? Supplementary means that the angles add up to 180 degrees. So in other words, angle 2, which is 90 degrees, plus some other angle must be equal to 180 degrees. Okay, so let's see over here. I know that 180 degrees is a straight line. If I start here and go around to 180 degrees, then I get a straight line, right? So one question that I can ask myself is, if I put angle 2 together with some other angle, do I get a straight line? If I do, then I know that together they're 180 degrees, which would make them supplementary. Well, let's look at the answer choices here. What about if we try angle 3? Let's try that one. Well, here's angle 3. This is angle 3 right over here. Now, if I start with angle 2 and go all the way through angle 2 and then through angle 3, does this make a straight line? No, it does not make a straight line. So angle 2 plus angle 3, I can see from the picture here, it would actually be a little bit less than 180 degrees. So angle 2 and angle 3 are not supplementary. What about angle 1? Do angle 1 and angle 2 form a straight line? Well, angle 1 is this angle right here, which is formed from these two line segments. Now again, if I start over here and then go through angle 2 and through angle 1, do I get a straight line? No, that is not a straight line. That also would be less than 180 degrees. Remember, I'm looking for 180 degrees because I want to know what angle is supplementary to angle 2. And supplementary means the angles add up to 180 degrees, and a straight line is 180 degrees. Well, let's try another one. Oh, I went too far there. I think I messed that whole thing up. So let me just draw angle 2 again. Okay, here's angle 2, which I know is 90 degrees. What if I were to try angle 5? Actually, I want to try angle 4 first. So angle 4 is this amount of rotation right here between these two line segments. So here's angle 4 and here's angle 2. Now, you might look at this and you might convince yourself that it does make a straight line, but actually it does not. Why do I say that? Because if I start here and I go through angle 2 and also through angle 4, I'm actually missing this whole part right over here. So it's not true. Even though it kind of looks like they make a straight line together from the picture, you have to remember to think about the rotation between this line segment and this line segment. If I start here and go through here, and then I start here and go through here, I did not actually go all the way from here to here, which would be 180 degrees. So angle 4 is also wrong. So angle 5, just by elimination, must be the correct answer. But wait a minute. Here's angle 2 again. There's angle 2. And here is angle 5. Okay, there's angle 5. And here is angle 2. How do I know for sure that angle 2 is actually equal, sorry, not equal, is supplementary to angle 5? How do I know that this angle here and this angle here add up to 180 degrees? Well, remember, we do know, because we see this symbol over here, angle 2 is 90 degrees. And what else do we know? We know that if we extend this line and also extend this line, then we can see that angle 2 and angle 5 are on the opposite sides of two intersecting lines. That makes them vertical angles. And what do we know about vertical angles? Vertical angles are always congruent. They're always equal to each other. So if angle 2 is 90 degrees, and angle 5 is equal to it, angle 5 is also 90 degrees. But wait a minute, 90 degrees plus another 90 degrees is equal to 180 degrees. So actually angle 2 and angle 5 do add up to 180 degrees, which makes them supplementary. So I can go ahead and submit that answer. All right, let's try the next one. Which angle is complementary to angle CFD? Okay, so I have to remember, what do they mean by angle CFD? Well, that goes back to naming angles, right? So they mean this right over here. Starting from C, we go to F, and then we go to D. So I want to know which angle is complementary. Here's angle CFD. Which angle is complementary to CFD? So that means this angle plus another angle must add up to 90 degrees. And remember, 90 degrees is a right angle. Well, if I look, let's try B. Okay, if I look over here at BFC, so from B, I go to F, and then I go to C. That's angle BFC. So if I start over here, and I go through this angle, and then through this angle, is this a 90-degree angle? Well, it kind of looks like a 90-degree angle. Is it actually a 90-degree angle? Yes, it is. How do I know that? I know that because I see this little symbol right over here, which tells me that this angle over here is a 90-degree angle. And I can see that this angle together with this angle form a linear pair. They're right next to each other, they're adjacent, and they also make a straight line together. So if this one is 90 degrees, then this one plus this one must be equal to 180 degrees. So I'm thinking to myself, 90 degrees plus x equals 180 degrees, x being this angle from here to here. Well, x must also be equal to 90 because 90 plus 90 is 180. So this angle must also be equal to 90 degrees, right? Which tells me that my original angle, CFD, plus this other angle, BFC, together they make 90 degrees, and that makes them complementary. So BFC is the correct answer. Let's try another one. Which angle is vertical to angle 5? Well, that should be easy by now. Here's angle 5. There's angle 5. And if I extend this line and extend this line, I can see that angle 2 is on the opposite side from angle 5, and they're both formed by the same two lines. So angle 2 is vertical to angle 5. Remember, vertical means that they're on opposite sides of two intersecting lines. Let's try another one. Which angles are adjacent to each other? What does adjacent mean again? Adjacent means that they are next to each other. More specifically, they share a common side between them and a common vertex. So which angles are adjacent to each other? So I have a choice here, 5 and 2. Let's see. Here's angle 5. And here is angle 2. Okay, angle 5 and angle 2, they actually do share a common vertex. However, they do not share a common side. Angle 5 and angle 2 would be vertical to each other, but they are not adjacent. They are not next to each other. Let's see. What's the other option? Angle 4 and angle 2. So here is angle 4. And here is angle 2. And once again, we can see that they share a common vertex. However, they do not share a common side. Both of the sides from angle 4 are different from both of the sides that make up angle 2. So they are also they're not right next to each other. There's this space in between them. What about angle 5 and angle 3? Here's angle 5. And here is angle 3. Okay, once again, we can see that they do share a common vertex, but they do not share a common side. So that's no good. All right, finally, okay, this better be right. What about angle 1 and angle 5? Here's angle 1. And here is angle 5. And you can see that to draw angle 5, I actually had to go over the same side as for angle 1. So angle 5 and angle 1 share a common side, and they also share a common vertex, which makes them adjacent. And you can see from the picture that they kind of look like they're next to each other, right? They are next to each other. All right, so that's our answer. Which angles are complementary to each other? Let's see here. So we have DGE and BGC. DGE and BGC. That would be DG. I don't know how I made this marker bigger again somehow. Hopefully somebody watching this video can tell me what I'm pressing on, because I honestly do not know what I'm pressing on. So DGE is this angle right over here. BGC, BGC is this angle over here. Are these angles complementary to each other? Do they add up to 90 degrees? There's nothing about this construction here that tells me that they add up to 90 degrees. There's no reason for me to think that they do. Let's try some other ones. What about EGF, EGF, and DGF? F. Okay, those would also not be complementary. What about BGC, BGC, and CGD, CGD? So that would be, I really want to make this smaller here. I don't know how I did it. Okay, anyway. Okay, so BGC, what is that one? From B to G to C, and then CGD. So that's going from C to G to D. And if we go from here through here, then even though I'm doing a really bad job of drawing this, this actually does make a 90-degree angle. And that means that this angle plus this angle equals 90 degrees, which by definition makes them complementary. And again, how do I know for sure that this is a 90-degree angle? Well, just to go through the logic of it pretty quickly, this angle over here, this is 90 degrees. So I know that this angle, if this angle is 90 degrees, and I know that from here to here, that's a straight line, so this angle plus this one must be equal to 180 degrees, right? So this plus this equals 180 degrees. So 90 plus what equals 180? Well, 90 plus 90 equals 180. So that means that from here to here, it is actually a 90-degree angle. So angle, once again, angle BGC plus angle CGD, it does make this 90-degree angle right over here. So they are complementary. All right. Which angles are supplementary to each other? 3 and 4. 3 and 4, I can see from the picture here, 3 and 4 would be complementary. So 3 and 4 make a 90-degree angle, but I'm looking for supplementary angles. That means angles that add up to 90 degrees. What about, so 3 and 4 is incorrect. What about 1 and 4? So this angle and this angle, there's no reason for me to think that they add up to 90 degrees. What about angle 3 and angle 2? Those also do not add up to to 180 degrees. What about angle 1 and angle 2? Well, angle 1 right over here, here's, okay, I really don't know how that got so big. All right, angle 1, okay, angle 1, yeah, oh, how is that happening? What am I doing? I don't want to buy this now. All right, sorry about that. I honestly do not know. Maybe if I do this and then go back to here to, oh, okay. And then does that? Ah, ha, 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 I figured it out. Okay. So, angle 1 and angle 2. Angle 1 is this angle right over here, which is formed from these two line segments. Angle 2 is this angle right over here, which is formed from these two line segments. And we can see that angle 1, if I start here and go through angle 1 and also through angle 2, then I'm going through 180 degrees, right? So I started with this line segment, and then I went from here all the way around to here. So I ended up at this line segment over here, and that is a straight line there. So angle 1 plus angle 2 must add up to 180 degrees, which means they are supplementary. So that's the answer for that one. Which angles are congruent to each other? Let's see here. I think this is the last one that I do before I skip a level. I probably went through the entire first level, and I might already be on the second level. Anyway, let's try, what about angles 2 and 4? So here's angle 2. There's angle 2. And here is angle 4. Well, those angles kind of look like they are congruent. Do we remember what congruent means? Congruent means that angles are equal to each other. So these angles, they do kind of look like they're equal to each other. Are they actually equal to each other? Well, one way that I could prove that they're equal to each other is if I know that they are vertical, because I know that all vertical angles are congruent. So are they vertical angles? Yes, actually they are vertical angles. If I take this line segment, which I used for angle 4, and just extend it, I get this side of angle 2. And if I take this line segment and extend it, I get the other side for angle 2. So both of these two angles are made from the same two lines. And they're on opposite sides of the two intersecting lines, so they are equal to each other. All right, so that's the answer there. Let's see, do I want to do this question, vertical? I think we talked a lot about vertical angles. I'm going to skip ahead to the next section. Which angle is vertical to CED? Okay, so this is the same thing that we've been doing, but you have to type in the answer now. So angle CED, so if I start from C and then go to E and then go to D, which angle is vertical to it? So that means that I have to take this line and extend it this way, and take this line and extend it this way, so I can see this angle is vertical to this angle, which also means that they're equal to each other, but I don't really have to know that now. Now I just have to name this angle, and I can see here that one name that I could give for it would be AEB. I could also name it BEA. That would also work. Either way is good. All right, next. Which angle is vertical to angle 4? That would be this angle on the opposite side, which is angle 1. Which angle is vertical to... It's giving me a lot of vertical angle questions. Okay, so again, I see that angle 2 is on the opposite side from angle 4. They're both formed from the same lines. So angle 2 is vertical to angle 4. Please tell me that I'm still recording and not talking to myself. I am. Okay. Sometimes I get paranoid about that. What is an angle that is supplementary to angle AGC? So remember, supplementary means that the angles add up to 180 degrees. And an easy way to tell, and well, if I have a straight line, again, we've talked about this. This is a little bit of a review. If I start from here and go around to here, that's 180 degrees. And that makes a straight line. So if I see that two angles make a straight line together, then I know that they must add up to 180 degrees, and therefore they must be supplementary, because supplementary just means that they add up to 180 degrees. So for this question here, I'm looking for angles that make a straight line. But I can't choose both of them. I can only choose one of them because IXL is telling me that one of them has to be AGC. So I have to use this angle as one of the angles. And I can actually see that if I start from here and just extend this line, then this angle right over here, together with that first angle that I drew, they make 180 degrees because they form a straight line together. So actually, this angle DGC must be supplementary with the first angle. So let's type in DGC for that one. Okay. Which angle is complementary to angle 3? Okay, well, I'm not going to go through the whole logic again, but this angle right over here is a right angle. It is 90 degrees. Okay, so I know that angle 3 from here to here, together with this angle, angle 2, together they make a right angle or a 90-degree angle. So if two angles add up to 90 degrees, that makes them complementary. So angle 2 is complementary to angle 3. The challenge zone. I think this is my longest video yet. Unless you're listening to this in the distant future, by which time I will have made many videos, and I don't know if this one is still going to be the longest one. But at the time that I'm making this video, it is the longest so far. Which angles are congruent to angle CGD? Well, let's over here. Where's C? Here's C. So I need to go. Ah, you're not going to trick me this time. I know what I did. There we go. Get out of here. Okay, so starting with C, I go to G, and then I go, where am I going? I'm going to D. So this angle over here is angle CGD. Which angles are congruent to CGD? Oh, and I have to select every single one, so there might be more than one. Well, remember that vertical angles are always equal to each other. So if I just take this line and extend it this way, and take this line and extend it this way, I can see that this angle is vertical to angle CGD. So I know that angle FGA must be congruent to CGD, because if they're vertical, then they're also congruent. Now, are there any other angles which are congruent? AGC, well, AGC together with this angle here, these would actually make a straight line. That does not make them congruent. That makes them supplementary. They would add up to 180 degrees. What about EGF? EGF. No, there's no reason for me to believe that this angle is the same as this first angle. What about FGB? FGB. No, this can't be, because I already know. Let me just draw out FGB. So I already know that this angle is equal to this one. So, but I also know that this angle here is clearly bigger than this angle. So if this angle equals this angle, but this angle is bigger than this angle, then this angle must also be bigger than this angle. So they are definitely not congruent. They're not equal to each other. So the only correct answer choice here is FGA. Alrighty. Which angles are complementary to angle BDC? All right. Well, good thing they gave me this little symbol here, which tells me that this angle here is this is a right angle. Okay, I know that because I see this little symbol here. Now, angle BDC is actually angle BDC is this angle right over here. So this angle plus what other angle would add up to 90 degrees, because complementary means they add up to 90 degrees. Well, from here to here, I can see that if I start from here, from this angle, and go through this angle, then I just created this 90-degree angle. So that means that this angle over here, which is called BDA, is complementary to BDC, because together they add up to a right angle, which is 90 degrees. So let me find BDA. I don't see BDA here, but I do see ADB, and that's just another way of naming that angle. Okay, so that's the correct answer there. Is it trying to trick me by giving me another BDA? No. Okay. All right, which angles are vertical to angle 3? Okay, we've done vertical angles so much now, right? So here's angle 3, which is made from this line and this line, and we can see that angle 5 is on the opposite side. So angle 5 is vertical to angle 3. All right. Complementary to angle 3. I think, yes. Yeah, so angle 3 plus angle 4, we can see here they make a right angle. Okay, and I know for sure that it's a right angle because angle 1 is a right angle, and this right over here is vertical to angle 1. So that means if this is a right angle, then this one must also be a right angle. So I know for sure that angle 3 plus angle 4 makes 90 degrees. All right, which angles are I think this is the last one. I was thinking that maybe there might be some questions which are different, but these are pretty much the same. All right, so I think this is the last one that I'm going to do. Which angles are supplementary to angle 1? Here's angle 1, right? Ah!
Angle 4.
I'm still recording, hun. That was my wife that you're just hearing making fun of me. Okay, I'm still recording. They can hear you. Thank you. I'll see you later. Alrighty. Okay. All right. Which angles are supplementary to angle 1? Here's angle 1, which happens to be a 90-degree angle because I see this little symbol here. So which angle plus angle 1 would be 180 degrees? Well, one thing that you might notice is that angle 1, if I start with this line segment and then I'm going to use yellow, and then just extend that all the way to here, then that gives me a straight line. So I know that angle 1 plus angle 2 plus angle 3 must add up to 180 degrees. However, this is only giving me angle 3 individually as an answer choice. So that's not going to work. Angle 1 plus angle 3, right? Or in other words, angle 3 by itself plus angle 1 does not add up to 180 degrees. I need to get angle 2 also, but it's not giving me that as an answer choice. Okay, angle 6 also doesn't work. Angle 5 also doesn't work. However, here's angle 1 again. I do see, once again, if I extend this line and extend this line, then angle 4 I can see is vertical to angle 1. And what do I know about vertical angles? They are equal to each other. And now I say to myself, wait a minute, I know something else about angle 1. Angle 1, because of this little symbol over here, angle 1 is 90 degrees, which means that angle 4 must also be 90 degrees. And if I do a little quick math, 90 plus 90, huzzah, it is equal to 180 degrees. So angle 1 and angle 4 add up to 180, which makes them supplementary. There we go. Oh, I better unselect that before I hit submit. Okay, we've done a zillion vertical angles, right? So I am going to leave it there. Hope that's helpful. If you have any questions, don't hesitate to reach out and ask me. Have a great day.